Picture this: a planet where it rains molten iron, another darker than coal, and one so light it could float in your bathtub if you had one big enough. The universe isn't just vast, it's packed with worlds so bizarre they make science fiction look tame. Astronomers have discovered planets that defy everything we thought we knew about how worlds work, and today we're counting down 25 of the strangest ones ever found. Each one of these cosmic oddballs will blow your mind more than the last, from diamond-covered super-Earths to ancient planets that have existed since nearly the beginning of time itself. If you think our solar system has all the answers, buckle up. You're about to have your whole perspective on planets turned upside down. These aren't just distant dots in space, they're extreme environments that challenge the very laws of physics as we know them. And we're taking you on a tour of the most jaw-dropping discoveries in modern astronomy. By the end of this journey, you'll never look at the night sky the same way again. So let's dive straight into the cosmic weirdness, starting with a planet that's literally worth a fortune. Now imagine a world where the very ground beneath your feet is worth more than all the wealth on Earth combined. Meet 55 Cancri, also known as the Diamond Planet, a cosmic jewel that would make any treasure hunter weak in the knees. This super-Earth, located about 40 light-years away in the constellation Cancer, isn't just sprinkled with diamonds, it's essentially one massive diamond orbiting its star. What makes this planet truly extraordinary is its composition. Scientists believe its surface is covered in layers of graphite and diamond, forming a glittering landscape unlike anything in our solar system. This happens because the planet is incredibly carbon-rich, with conditions so extreme that carbon atoms get compressed into diamond structures. To put it simply, if you could stand on this world, which you absolutely couldn't, you'd be walking on a crust made of solid diamond. But don't start planning your space mining expedition just yet. 55 Cancri is a scorching nightmare, with surface temperatures reaching a blistering 2,400 degrees Celsius, hot enough to vaporize most metals. It orbits so close to its host star that a full year there lasts a mere 18 hours. That means birthdays would come and go before you could even finish a single Earth day. How did such a bizarre world come to exist? Astronomers propose two possibilities. One theory suggests it formed in a carbon-heavy region of its planetary system, where there was far more carbon than oxygen during its creation. Another idea is that it was once a gas giant like Jupiter, but its outer layers were stripped away by its star, leaving behind a dense, diamond-rich core. Either way, this planet proves that when it comes to cosmic wonders, reality can outshine even the wildest fiction. And while we may never visit this glittering inferno, its discovery reshapes our understanding of what's possible in the universe. Who knew that diamonds, prized gems on our planet, could be as common as rocks in the right corner of space? This is just the first stop on our tour of cosmic oddities, and trust me, the universe has even stranger sights in store. Now let's float away from the Diamond Planet to something even more baffling. A world that defies the very laws of density. Meet HAT P1b, nicknamed the Puffy Planet, a gas giant so light and bloated that it makes Jupiter look compact. Located around 450 light-years away in the constellation Lacerta, this cosmic oddity is larger than Jupiter, yet only half its mass, making it one of the least dense planets ever discovered. Picture a planet so inflated that if you could find a bathtub big enough, it would actually float like a beach ball in water. That's the mind-bending reality of HAT P1b. While Jupiter is already massive, this planet stretches nearly 1.5 times its width while weighing significantly less. Scientists are still scratching their heads over how something so large can be so light. So what's causing this extreme puffiness? One leading theory points to intense internal heat. Unlike Jupiter, which radiates some of its own heat from formation, HAT P1b might be getting an extra thermal boost, possibly from tidal forces as its star stretches and squeezes the planet during its orbit. This constant gravitational tug of war could be pumping energy into the planet's core, causing its atmosphere to expand like a balloon left in the sun. Another idea suggests that the planet's upper atmosphere is absorbing an unusual amount of stellar radiation, superheating its outer layers and making them swell. But here's the real kicker: HAT P1b orbits its star at just 1/20th of the distance between Earth and the Sun. That means it completes a full orbit in just 4.5 Earth days, basking in scorching temperatures that likely contribute to its bizarre structure. While most gas giants form farther out in their systems and migrate inward, this planet's ultra-close position adds another layer of mystery to its unusual traits. The discovery of worlds like HAT P1b forces astronomers to rethink how planets evolve under extreme conditions. It challenges our understanding of atmospheric physics and proves that the universe has a flair for creating celestial curiosities we never imagined possible. And if you thought this one was strange, just wait, the cosmos has even more bizarre surprises up its sleeve. Shifting from the cosmic oddity of the puffy planet, let's dive into the shadows of one of the universe's most enigmatic worlds, TRES-2b, the darkest planet ever discovered. Imagine a world so pitch black that it reflects less than 1% of the light that hits it, making it darker than fresh asphalt or even black acrylic paint. Located about 750 light-years away in the constellation Draco, this Jupiter-sized exoplanet is a true cosmic mystery, absorbing nearly all the light from its star instead of reflecting it back into space like most planets. Scientists call TRES-2b the dark planet for good reason. It's so light-absorbent that if you could float nearby, you'd struggle to see its outline against the void of space. Unlike Jupiter, which reflects about a third of sunlight thanks to its bright ammonia clouds, this world is shrouded in an atmosphere that acts like a celestial black hole swallowing photons whole. But here's the eerie twist: it isn't completely invisible. The planet emits a faint, haunting red glow like smoldering embers in a dying fire, caused by its scorching temperatures of over 1,800 degrees Fahrenheit. That glow is the only hint of its presence in the darkness. So what makes this planet so unnaturally dark? One leading theory points to its atmosphere's chemical makeup. Researchers suspect it's loaded with light-absorbing substances like vaporized sodium and potassium, or even exotic compounds we haven't identified yet. These elements could act like a cosmic sponge, soaking up starlight instead of scattering it. Another possibility is that the planet's extreme heat prevents the formation of reflective clouds, leaving its atmosphere smooth and light-devouring. Some scientists go further, speculating that TRES-2b might be carbon-rich, with a haze of soot-like particles turning its skies into an inky abyss. But the strangeness doesn't end there. TRES-2b orbits its star at just 3 million miles, so close that it's tidally locked, with one side perpetually scorched by stellar radiation while the other drowns in eternal night. This creates a surreal environment where the day side might be hot enough to vaporize metals, yet the faint red glow suggests heat distribution is defying expectations. The discovery of TRES-2b forces us to rethink what's possible in planetary science. It challenges our assumptions about how atmospheres behave under extreme conditions and proves that the universe has a flair for the dramatic. If there's one thing this world teaches us, it's that darkness isn't just the absence of light. It can be an active, seething phenomenon all its own. And just when you think you've seen it all, the cosmos unveils another enigma waiting to be unraveled. Now let's journey from the eerie darkness of TRES-2b to a world where the skies rain molten metal WASP 76b, a planet so scorching it defies every expectation of what we thought possible. Picture a gas giant where daytime temperatures soar to a staggering 2,400 degrees Celsius, hot enough to vaporize iron and turn it into shimmering atmospheric mist. But here's where it gets even wilder. As this hellish world rotates, its night side cools just enough for that vaporized iron to condense and plummet back down as a surreal, glowing rain of liquid metal. WASP-76b orbits its star so closely, just 1/20th the distance between Earth and our Sun, that it's tidally locked, meaning one side is forever baked in brutal sunlight while the other languishes in perpetual darkness. This extreme contrast creates a nightmare of atmospheric dynamics. On the day side, metals like iron don't just melt, they evaporate completely, turning into a metallic vapor that's carried by supersonic winds toward the night side. But how do we know this is happening? Astronomers used a technique called spectroscopy to detect iron vapor in the planet's atmosphere. As starlight filtered through WASP-76b's air, specific wavelengths were absorbed by iron atoms, leaving telltale fingerprints in the light we observe. Even more fascinating, those signatures disappeared on the night side, proof that the iron was cooling and condensing out of the atmosphere, likely forming droplets that rain downward in a fiery deluge. The physics at play here are mind-bending. Winds on WASP-76b likely scream across the terminator, the boundary between day and night, at speeds exceeding several thousand miles per hour, ensuring the iron vapor doesn't just linger on the hot side. And because the night side is still brutally hot by earthly standards, though cooler than the day side, the iron rain probably falls as superheated droplets, creating a landscape where metal rivers could theoretically flow beneath a turbulent, metallic sky. What makes WASP-76b truly exceptional is how it stretches our understanding of planetary atmospheres. Most gas giants like Jupiter have relatively stable weather systems. But this world is a maelstrom of extremes where chemistry and physics collide in ways we've never seen. It's a reminder that the universe doesn't just create strange worlds, it engineers them with a level of drama that even our boldest sci-fi can't match. And just when you think WASP-76b can't get any more alien, consider this. If you could stand on its night side, though you'd be vaporized instantly, you might witness a sky streaked with glowing molten metal, a natural phenomenon so extreme it makes even the wildest weather on Earth seem tame by comparison. From molten metal rain to a world frozen in time, let's turn our gaze to Gliese 581g, a planet so bizarre it's been nicknamed the Eyeball Planet. Imagine a world where one side is forever bathed in sunlight, while the other is locked in eternal darkness, creating a striking visual straight out of science fiction. This tidally locked planet, orbiting a dim red dwarf star, might just be one of the most intriguing candidates for extraterrestrial life we've ever discovered. Gliese 581g sits snugly in what astronomers call the habitable zone, the sweet spot where temperatures could allow liquid water to exist. But here's the catch: because it's tidally locked, one hemisphere always faces its star, and the other stares endlessly into the frozen void of space. The result, a planet split into two extreme realms. The day side, constantly cooked by stellar radiation, could host a vast, roiling ocean, while the night side plunges into temperatures so cold that even the atmosphere might freeze solid, creating a glacier-covered wasteland. But between these two extremes lies a narrow twilight ring, a sliver of potential habitability where conditions might be just right. Scientists call this the Terminator Line, and it's here that the Eyeball Planet gets its name. Picture a world with a colossal, star-facing pupil of liquid water, surrounded by an icy iris that gradually gives way to permanent frost on the dark side. This bizarre configuration could create perpetual storms along the boundary, where scorching winds collide with freezing air, driving weather patterns unlike anything on Earth. The real question, of course, is whether life could survive in such a place. Red dwarfs like Gliese 581 are notorious for their violent flares, bombarding nearby planets with radiation. But life on Earth has proven remarkably resilient, thriving in everything from acidic hot springs to deep sea vents. On Gliese 581g, organisms might cluster in the Terminator's delicate balance, drawing energy from chemical reactions or even the star's faint light. Some theories suggest that photosynthetic life could exist in the shallow waters of the day side, while extremophiles eke out an existence in the twilight's edge. What makes this world so fascinating isn't just its potential for life, but how it challenges our assumptions about where life can exist. We often imagine alien worlds as Earth-like, with regular days and nights. But Gliese 581g forces us to think differently, to consider that life might flourish in perpetual twilight, or even beneath ice sheets, shielded from a hostile cosmos. It's a reminder that the universe doesn't play by our rules, and that life, if it's out there, might be far stranger than we've ever dreamed. And just when you think the eyeball planet can't get any more intriguing, consider this. If life does exist there, its evolutionary path would be utterly alien. Creatures might migrate eternally along the Terminator, chasing an endless sunset that never quite arrives, or adapt to cycles of extreme heat and cold that make our seasons look mild by comparison. Gliese 581g isn't just a planet. It's a glimpse into the infinite creativity of cosmic possibility. Now let's shift gears to a world where time flies faster than you can blink. PSR J1719-1438b, the fastest planet ever discovered. This cosmic speed demon completes an entire orbit around its star in just 2 hours, meaning a full year there passes in less time than it takes to watch your favorite movie. This planet isn't just fast, it's also one of the most extreme survivors in the universe. It circles a pulsar, the dense, spinning corpse of a star that once went supernova. Somehow, this planet endured that catastrophic explosion, a testament to its incredible resilience. Scientists believe its core might be pure diamond, compressed under unimaginable pressure during the star's violent death throes. The numbers here are staggering. PSR J1719-1438b zooms through space at 1.4 million miles per hour, bound to its pulsar host by gravity's unrelenting grip. The pulsar itself spins hundreds of times per second, blasting the planet with intense radiation and magnetic fields. Yet against all odds, this world persists. How did it form? The leading theory suggests it was once a massive star itself, orbiting its companion. When that companion exploded, the outer layers were blasted away, leaving behind a stripped-down core of crystallized carbon, essentially a giant diamond. Now locked in this breakneck dance, the planet endures conditions no Earth-like world could survive. What would it be like to stand on its surface? Forget about it, tidal forces would shred you instantly, and the radiation would fry anything alive. But as a cosmic oddity, this planet teaches us something remarkable. Even in the aftermath of stellar destruction, new worlds can emerge, defying expectations. This pulsar planet isn't just a curiosity, it's a reminder of how diverse planetary systems can be. While we search for Earth-like worlds, places like this stretch our imagination, showing us that the universe has far stranger things in store than we've yet dreamed. But now, let's slow down and journey back in time, way back, to meet the oldest known planet in the universe, PSR J1720-26b. This ancient world is a staggering 12.7 billion years old, meaning it formed when the cosmos itself was barely a billion years young. To put that in perspective, this planet existed before Earth, before our Sun, even before most of the stars in our galaxy had ignited. This relic orbits not one but two dead stars, a pulsar and a white dwarf, locked in a gravitational waltz within the dense star cluster Messier 4. The fact that it still exists at all is nothing short of miraculous. Consider the violence it has witnessed, the death of its original host star, the catastrophic supernova that birthed the pulsar, and the slow expiration of its companion star into a white dwarf. Against all odds, this planet clung to existence through eons of cosmic chaos. How did it survive such turmoil? Astronomers believe it may have originally orbited a sun-like star, which later collapsed into the white dwarf we see today. When a neighboring star went supernova, the blast could have flung this planet into a new orbit around the resulting pulsar. Alternatively, it might have been captured by the pulsar white dwarf pair later in their dance. Either way, its endurance defies expectations. Planets rarely survive the violent deaths of their stars, let alone two. What's equally fascinating is what this planet tells us about the early universe. Its existence proves that planets formed incredibly quickly after the Big Bang, in an era when heavy elements were far scarcer than they are today. This challenges the assumption that planet formation required the dust-enriched environments of later cosmic generations. PSR J1720-26b is a living fossil, offering clues about how the first planetary systems took shape. Unlike the diamond planet or molten iron worlds, this ancient survivor isn't extreme in temperature or composition. It's likely a gas giant similar to Jupiter. But its true marvel lies in its longevity. While younger planets boast fiery skies or bizarre materials, this one whispers secrets from the universe's infancy. Imagine the stories it could tell, the rise of the first galaxies, the birth and death of countless stars, all witnessed from its lonely outpost. As we search for planets beyond our solar system, finds like this remind us that the universe has been crafting strange and resilient worlds for far longer than we ever imagined. And who knows, somewhere out there, even older planets may await discovery, rewriting the history of cosmic evolution once again. Now, let's venture into the cosmic wilderness to meet a planet that defies the rules, a lone wanderer untethered to any star. This is CFB D-SIR-2149-0403, a rogue planet drifting through the void of space like a ghost ship in the night. Unlike every other world we've explored so far, this one doesn't orbit a star. It's free, solitary, and utterly independent, a rebel in a universe where planets are usually bound by gravity's chains. So how does a planet end up all alone? Astronomers have a few theories. Some rogue planets might form the traditional way, condensing from swirling disks of gas and dust around newborn stars, only to be violently ejected later, perhaps by a gravitational kick from a sibling planet or a passing star. Others could form directly from collapsing gas clouds, much like stars do, but without enough mass to ignite nuclear fusion. Imagine a failed star, too small to shine but too large to be just a planet. These cosmic orphans might be far more common than we ever imagined, lurking in the darkness between stars, invisible to most telescopes. What's truly fascinating about CFB D-SIR-2149-0403 is that it's not entirely cold and dead. It glows faintly with residual heat, a remnant of its fiery birth. Think of it like a dying ember in a cosmic campfire, still warm long after the flames have gone. This internal warmth, likely from gravitational contraction or the slow decay of radioactive elements, means rogue planets could potentially host thick atmospheres or even hidden oceans beneath icy shells. Some scientists speculate that these wandering worlds, insulated by dense atmospheres, might retain enough heat to support liquid water for billions of years, raising the tantalizing possibility of life untethered from any star. But here's the mind-bending part. Rogue planets might outnumber stars in our galaxy. Current estimates suggest there could be billions, even trillions, of these nomads drifting unseen. They're incredibly hard to detect since they don't reflect starlight, but advances in infrared astronomy, catching the faint glow of their warmth, are finally bringing them into focus. CFB D-SIR-2149-0403 is just one of the few we've spotted so far, a hint at a vast hidden population. Imagine the sky from the surface of such a world. No sunrise, no sunset, just perpetual night with distant stars as faint, unmoving dots. Yet this isn't necessarily a lifeless void. If rogue planets do harbor internal heat and liquid water, they could be dark, isolated sanctuaries for extremophile life, thriving in ways we've yet to comprehend. And who knows, as we peer deeper into the interstellar dark, we might find that these lonely wanderers are far stranger and far more numerous than we ever dreamed. The discovery of rogue planets reshapes our understanding of what a planet can be. They challenge the very definition, proving that worlds don't need stars to exist and that the universe is far wilder and far more inventive than we once believed. Shifting our gaze from the silent solitude of rogue planets, we now encounter a world where chaos reigns supreme, a tempest so violent it defies imagination. Meet HD 189733b, a planet where the skies aren't just unfriendly, they're downright deadly. This cobalt blue jewel from afar hides a nightmare of supersonic winds and razor-sharp rain, making it one of the most extreme weather hotspots in the known universe. At first glance, HD 189733b might look serene, its deep blue hue reminiscent of Earth's oceans, but don't let that tranquil appearance fool you. This gas giant, orbiting dangerously close to its host star, is a maelstrom of unimaginable fury. Winds here don't just blow, they scream at an astonishing 5,400 miles per hour, 7 times the speed of sound. To put that into perspective, the strongest hurricanes on Earth top out at around 200 miles per hour. On this planet, winds would strip flesh from bone in seconds, carrying with them not water droplets but molten glass. So how does such a hellish environment come to exist? The answer lies in the planet's tortured atmosphere. HD 189733b is tidally locked, meaning one side always faces its star, baking under relentless heat, while the other side languishes in eternal darkness. This extreme temperature difference over 1,000 degrees Celsius between day and night creates a pressure imbalance that fuels those monstrous winds. The scorching day side vaporizes silicates in the atmosphere, which then condense into tiny glass particles on the cooler night side. These particles are swept up by the hyperwinds, creating horizontal storms of molten glass that shriek across the sky at bullet speeds. But why does this violent world appear so strikingly blue? Unlike Earth, where oceans scatter sunlight to create our blue tint, HD 189733b's color comes from something far more exotic, a haze of silicate particles in its upper atmosphere. These minuscule glass fragments scatter blue light, much like our own sky, while absorbing red wavelengths. The result is a deceptively beautiful azure glow, masking the planet's true nature as a cosmic slaughterhouse. Here's another twist. Astronomers initially thought this planet's blue color might indicate vast water oceans, raising hopes of a habitable world. Instead, they found a place where water couldn't exist in any recognizable form. The realization was a sobering reminder that in the universe, appearances can be fatally deceptive. What makes HD 189733b so valuable to scientists isn't just its shock value, it's a laboratory for studying atmospheric extremes. By analyzing how its atmosphere behaves under such brutal conditions, we gain insights into the limits of planetary weather systems, helping us refine our models for even more exotic worlds. And who knows, someday, the secrets buried in its sapphire skies might help us understand the atmospheres of distant, potentially habitable planets, worlds where the weather is gentle enough for life to take root. This hyperwind planet stands as a testament to nature's capacity for both beauty and terror, a reminder that the universe doesn't care about our expectations. It invents, it distorts, and it astonishes, often all at once. From the howling tempests of hyperwind planets, let's journey to a celestial spectacle straight out of science fiction, where 3 suns dance across the sky in an endless cosmic ballet. Meet HD 131399b, a teenage gas giant with a view unlike any other in the universe. Imagine standing on this distant world, where the horizon might be lit by multiple suns casting overlapping shadows, creating sunsets that paint the sky in triplicate. This extraordinary planet belongs to an exclusive club. It's one of the few known worlds orbiting not 1, not 2, but 3 stars simultaneously. Located about 340 light-years away in the constellation Centaurus, this system defies our single-star expectations. The primary star, HD 131399a, is orbited by two smaller companion stars locked in their own tight waltz. The planet itself circles the largest star at a distance roughly twice that of Pluto's orbit around our Sun, completing one revolution every 550 Earth years. That's a single season lasting longer than entire civilizations here on Earth. Here's where it gets surreal. For about half of its marathon year, inhabitants would experience near constant daylight as all three stars cluster together in the sky. But as the planet progresses in its orbit, the stars begin to separate, eventually creating staggered sunrises and sunsets. At certain points, you might witness one star dipping below the horizon while another remains high in the sky, with the third just peeking over the opposite horizon. The lighting would shift from golden hues to deep blue tones as different stars dominate the sky, casting ever-changing triple shadows across the landscape. You might wonder, how can such a complex system remain stable? Gravity is the choreographer here. The two smaller stars orbit each other closely, while together they circle the primary star at a much greater distance. This hierarchical arrangement prevents gravitational chaos. The planet wisely keeps its distance from this stellar tango, orbiting far enough to avoid being flung into space. In fact, astronomers were stunned to find a planet surviving in this configuration. Current models suggested such worlds would be unstable. Its discovery forced us to rethink how planets might form and persist in multi-star systems. The planet itself is no less peculiar. Estimated at about 16 million years old, a cosmic infant compared to Earth, it's still glowing from the heat of its formation, with temperatures around 1,000 degrees Fahrenheit. Its atmosphere likely swirls with vibrant bands of cloud, constantly reshaped by the competing gravitational tugs and varying stellar heating. What makes HD 131399b so revolutionary is what it teaches us about the diversity of planetary systems. If worlds can thrive amid three suns, what other impossible configurations might exist? Every discovery like this shatters our assumptions, proving the universe is far more inventive than our textbooks predicted. As we continue searching the cosmos, who knows, we might yet find a planet with 4 sunrises, or skies perpetually alight with stellar fire. Until then, this triple sun wonder remains a dazzling reminder that the rules of celestial mechanics are more like suggestions in the grand cosmic playbook. Now, let's leave the triple sun spectacle behind and venture to a world where the very laws of physics seem to twist into something unrecognizable. Gliese 436b is a Neptune-sized enigma that defies every expectation. A place where water shouldn't flow, but instead forms hot ice, and where methane doesn't just linger in the atmosphere but sculpts alien landscapes into dunes. This bizarre world orbits a red dwarf star just 33 light-years away, close enough for detailed study yet strange enough to baffle astronomers. At first glance, you might mistake it for a typical hot Neptune until you peer beneath the surface, literally. Despite scorching temperatures around 800 degrees Fahrenheit, Gliese 436b shouldn't exist as we see it. Here's the puzzle. Under that blistering heat, water molecules on this planet are crushed by atmospheric pressures over 80 times heavier than Earth. Instead of evaporating, the water gets compressed into an exotic state nicknamed hot ice, a solid form of water that somehow persists at temperatures that would boil it away on any other world. Imagine icebergs that don't melt, not because they're cold, but because the weight of the entire atmosphere is holding them together. But the surprises don't stop there. The planet's outer layers are rich in methane, which should break down under such extreme heat. Yet somehow, methane here refuses to obey the rules. Instead of dissipating, it appears to gather on the planet's cooler night side, forming vast fields of dunes. Picture endless stretches of rolling sand like methane, except this isn't sand at all, but hydrocarbon particles swept into strange formations by supersonic winds. What makes Gliese 436b so revolutionary is how it forces scientists to rewrite the textbooks. Planetary models predicted that worlds this close to their stars would lose their atmospheres entirely, either boiled away or stripped by stellar winds. Yet here it sits intact, with an atmosphere denser than anticipated and chemistry that defies logic. Some theorize that the planet's interior might be generating fresh methane, replenishing what the star destroys. Others suggest its extreme gravity creates a cold trap, pulling methane downward faster than heat can destroy it. The more we study this world, the clearer it becomes. Gliese 436b is a laboratory for the impossible. It challenges our understanding of how matter behaves under extreme conditions, revealing gaps in our knowledge of planetary evolution. If water can become ice while glowing red-hot, and methane can form dunes where it should vanish, what other cosmic rules are waiting to be broken? Every discovery like this stretches the boundaries of what we thought possible, reminding us that the universe isn't just stranger than we imagine, but often stranger than we can imagine. Next up, we'll encounter a celestial newborn, a planet so young, it's practically still in its cosmic crib. But for now, let this methane-draped marvel sink in, a world where the familiar becomes alien and the impossible becomes routine. Now, let's take a step back in cosmic time, way back, to witness the birth of a planet still fresh from the celestial nursery. Meet V830 Taube, a gas giant so young, it makes Earth's 4.5 billion years seem like an eternity. At just 2 million years old, this world is practically a newborn in planetary terms, offering us a rare glimpse into the chaotic early stages of planet formation. Imagine a construction site, but instead of steel beams and concrete, this one's made of swirling gas and dust. V830 Taube orbits a star still surrounded by the remnants of its protoplanetary disk, the primordial soup from which planets emerge. Unlike mature systems where planets have settled into stable orbits, here we see the raw, messy process of creation in action. The star itself is a toddler, barely settling into its nuclear fusion phase, while its planetary companion is still growing, possibly even pulling in more material from the disk around it. What makes this planet so revolutionary isn't just its youth, it's the window it opens into how gas giants form. Conventional wisdom suggested giant planets like Jupiter take tens of millions of years to assemble, slowly gathering gas around a solid core. But V830 Taube defies that timeline. It's already nearly as massive as Jupiter, yet it exists in a system where the dust hasn't even fully cleared. This discovery has sent theorists back to the drawing board, questioning whether some planets might form through a faster, more violent process like gravitational instabilities that collapse parts of the disk directly into planets. Studying V830 Taube is like finding a fossil of a baby dinosaur. It captures a fleeting moment in evolution we rarely get to see. By analyzing its orbit, composition, and the structure of its surrounding disk, astronomers can test theories about how planetary systems take shape. For instance, its close orbit hints that gas giants might migrate inward early in their lives, reshaping systems before they stabilize. And its sheer size at such a young age challenges the idea that all planets grow slowly and steadily. To put its youth into perspective, if Earth's lifetime were a 24-hour day, V830 Taube would have existed for barely 1 minute. Yet in that blink of cosmic time, it's already a fully formed giant, a testament to the dynamic and sometimes explosive nature of planet formation. As we continue our journey through the cosmos, remember this: every planet tells a story, but the youngest ones, like V830 Taube, reveal the opening chapters, the dramatic, unpredictable beginnings that shape everything that follows. Next, we'll visit a world straight out of science fiction, where twin suns cast shadows in a dance as old as time itself. Now, picture this: a world where two suns rise and set in an endless celestial ballet, just like Luke Skywalker's home in Star Wars. Welcome to Kepler 16b, the first confirmed planet orbiting a pair of stars, proving that science fiction sometimes becomes science fact. This bizarre world, affectionately nicknamed the Tatooine planet, doesn't just defy our expectations, it rewrites the rulebook on where and how planets can exist. Binary star systems, where two stars orbit each other, were once thought to be too chaotic for planets to form. The gravitational tug of war between the stars would, in theory, tear apart any budding planetary material. But Kepler 16b shattered that assumption. It orbits both stars at a safe distance, about 65 million miles out, similar to Venus's orbit in our solar system. The stars themselves are smaller and cooler than our Sun, one about 2/3 its mass and the other just a fifth, locked in a 41-day dance around each other. What makes this planet truly surreal is the light show it experiences. Imagine standing on its surface, though you wouldn't want to, given its freezing -100 degrees Fahrenheit temperatures. The twin suns would cast ever-changing shadows, sometimes overlapping, sometimes separate, creating a kaleidoscope of sunrises and sunsets. During certain parts of its 229-day year, both stars would eclipse each other from the planet's perspective, plunging parts of the world into temporary darkness. Kepler 16b itself is a cold, gaseous world, roughly the size of Saturn but with a density closer to Jupiter's. Its composition mostly hydrogen and helium with traces of heavier elements hints at a formation story unlike anything in our solar system. Astronomers believe it likely formed farther out in the disk of material surrounding the stars, then migrated inward over time. This challenges the idea that binary systems scatter planets outward, proving they can hold onto their worlds despite the gravitational chaos. The discovery of Kepler 16b wasn't just a milestone, it opened the floodgates. Since its confirmation in 2011, dozens of other circumbinary planets have been found, showing that Tatooine-like worlds might be common in the cosmos. Some even orbit within the habitable zones of their stars, raising tantalizing questions about the potential for life under twin suns. This planet also teaches us about resilience. Surviving in a binary system means withstanding wild temperature swings and gravitational stresses, yet Kepler 16b has persisted for billions of years. Its existence proves that the universe finds a way to build planets in even the most unlikely places. As we marvel at this real-life Tatooine, remember, every strange world we uncover expands our understanding of what's possible. Next, we'll dive into an ocean unlike any other, a planet where the very idea of land is just a distant dream. Now, let's trade twin sunsets for endless ocean horizons, because J1719-14b isn't just a water world, it's a planet that drowns every definition of ocean we've ever known. Imagine an entire planet where not a single speck of land breaks the surface, where the very idea of a shoreline is science fiction. But this isn't your peaceful, Earth-like sea. J1719-14b's waters are so deep, so pressurized, and so blisteringly hot that they defy physics as we understand it. Discovered orbiting a dim red dwarf star just 40 light-years away, this Neptune-sized planet is shrouded in a steam-thick atmosphere so dense, it's more like a planetary sauna. Surface temperatures soar past 400 degrees Fahrenheit, hot enough to boil water, except here, the pressure is so immense that the liquid can't escape as vapor. Instead, scientists believe the entire surface could be a supercritical fluid, a bizarre state where liquid and gas merge into something neither truly water nor steam. Picture an ocean that behaves like dense fog, swirling under an oppressive perpetual haze, but the real mystery lies beneath. The crushing pressure, thousands of times stronger than Earth's deepest trenches, might be squeezing water into exotic forms of ice. Not the icy flakes we know, but phases like Ice 7 or Ice 10, crystalline structures that form under such extreme conditions that they're hotter than boiling water yet remain solid. Some theories suggest the planet could have a layered interior, a sloshing supercritical ocean atop a mantle of these fiery ices wrapping around a rocky core. It's a world where water, the substance we associate with life, becomes utterly alien. What makes GJ1214b even more intriguing is its atmosphere's composition. Hubble observations revealed it's rich in hydrogen and helium but suspiciously lacking in water vapor, a paradox for a planet that might be mostly H2O. One explanation, a thick, global cloud layer of salts or zinc sulfide compounds blocking our view of the chaos below. These aren't rain clouds, they're more like a planetary scale pressure cooker lid, trapping heat and moisture in a cycle we can barely comprehend. The existence of such a world forces us to rethink habitability. While GJ1214b is far too hostile for life as we know it, it proves that water can exist in volumes and states we never imagined possible. If this planet has taught us anything, it's that ocean is a word too small for the universe's creativity. And speaking of cosmic creativity, our next destination takes us to a planet where the ground itself is aflame, a world where volcanoes don't just erupt, they define existence. Now, let's leave the suffocating steam of GJ1214b behind and step onto a planet where the very ground is on fire. K2141b isn't just a world with volcanoes, it's a planet where the entire surface is a churning, molten nightmare. This super-Earth, orbiting so close to its star that a year lasts less than 7 hours, is so scorchingly hot that rocks don't just melt, they evaporate. Imagine standing on a shore where the ocean isn't water but a 1,000-mile deep sea of magma, glowing white-hot under a sky that literally rains pebbles. Discovered in 2018, K2141b is tidally locked, meaning one side permanently faces its star while the other is plunged into eternal darkness. The day side reaches temperatures of over 5,000 degrees Fahrenheit, hotter than some stars, causing the rocky surface to melt into a vast, bubbling lava ocean. But here's where it gets even stranger. The extreme heat vaporizes minerals like sodium and silicon monoxide, creating an atmosphere not of gas but of rock vapor. As these mineral clouds drift toward the night side, where temperatures plummet to negative 300 degrees, they condense and fall back as rocky precipitation. Picture this, a planet where the weather forecast is scorching magma tides with a chance of pebble storms. The tidal forces at play here are mind-bending. K2141b's proximity to its star creates gravitational stretching so intense that the planet is likely shaped more like an egg than a sphere. This constant tug of war generates enough internal heat to fuel perpetual volcanic activity, essentially recycling the planet's surface. Lava erupts, vaporizes into the atmosphere, and then solidifies back into rock, only to melt again in an endless, hellish cycle. Some scientists compare it to a cosmic blacksmith's forge, where the planet's crust is continually being hammered and reshaped. What fascinates researchers most is how K2141b challenges our understanding of planetary formation. Most lava worlds we've discovered are gas giants, but this one is rocky, suggesting it might have started as a Neptune-like planet that had its atmosphere boiled away, leaving behind a naked, molten core. Or perhaps it's a super-Earth born in the furnace of its star's infancy, forever trapped in a dance of destruction and rebirth. Either way, it's a brutal reminder that the universe doesn't just create planets, it forges them in fire. And just when you think space can't get any weirder, our next stop takes us to a planet that spins in the wrong direction, a cosmic rebel defying every rule of planetary motion. Now let's take a sharp turn from molten rock storms to a planet that flips the script entirely, WASP-17b, the cosmic rebel spinning the wrong way. This isn't just a quirky detail, it's a full-blown astronomical mystery. Picture a gas giant twice the size of Jupiter, lazily drifting around its star, but here's the kicker. It's orbiting in the exact opposite direction of its star's rotation. It's like watching a car drive backward on a freeway while everyone else obeys traffic laws. Discovered in 2009, WASP-17b was the first exoplanet found with this bizarre retrograde orbit, and it shattered everything astronomers thought they knew about how planets form. Normally, planets coalesce from the same spinning disk of gas and dust as their star, which means they should orbit in the same direction like marbles rolling around the edge of a bowl. But WASP-17b didn't get the memo. Its backward journey suggests a violent past, possibly involving a catastrophic collision with another massive object that sent it careening in reverse. Alternatively, gravitational tug-of-wars with undiscovered planets in the system could have slowly twisted its orbit over millions of years. What makes this even wilder is the planet's own extreme traits. Despite its massive size, WASP-17b is incredibly lightweight, half the density of Jupiter, giving it a puffed-up, almost cotton candy-like structure. Scientists suspect its atmosphere is stretched and heated by the star's intense radiation, causing it to balloon outward. But here's the real head-scratcher. How does such a fragile planet survive the gravitational chaos required to flip its orbit? Some theories propose it migrated inward from the outer system, getting slingshotted by passing bodies, while others suggest the star's magnetic field played a role in rearranging the planetary disk. The implications are staggering. If a planet as large as WASP-17b can defy the rules, what does that mean for our models of solar system formation? It hints that young planetary systems might be far more chaotic than we imagine and more like celestial bumper cars than orderly clockwork. Even today, astronomers are hunting for other retrograde worlds to see if this is a cosmic fluke or a hidden pattern. And just when you think you've seen it all, our next destination takes us to a planet so dense it defies logic, a world where an entire gas giant's worth of mass is packed into a space no bigger than Earth. Switching gears from cosmic rebels to cosmic oddballs, let's zoom in on TOI-849b, a planet that shouldn't exist. Imagine a world the size of Neptune but with the density of Earth. That's like stuffing a balloon's worth of gas giant into a rock-solid suitcase. This bizarre celestial body is the first of its kind ever discovered, a naked planetary core stripped bare and exposed to the universe. Discovered in 2020 by NASA, a transiting exoplanet survey satellite, TOI-849b orbits so close to its star that a full year lasts just 18 hours. Surface temperatures here soar above 1,500 degrees Celsius, hot enough to vaporize steel. But the real shocker, this planet is missing something critical, its atmosphere. Normally, a Neptune-sized world would be wrapped in a thick blanket of hydrogen and helium, but TOI-849b is eerily bare, like a fruit peeled down to its core. So how did this planet lose its gaseous envelope? Astronomers have two leading theories. First, it might have formed as a gas giant, only to have its atmosphere ripped away by the intense radiation and gravity of its star, a process called photoevaporation. Picture a cosmic sandblaster relentlessly scouring away layers until only the dense core remains. The second theory is even more intriguing. TOI-849b could be a failed gas giant, a planet that started gathering its gaseous shell but somehow stalled mid-formation. Maybe the protoplanetary disk around its star ran out of material, leaving the core forever unfinished. What makes this discovery groundbreaking is that it gives us an unprecedented look at a planetary core, something we'd never see in our own solar system. Gas giants like Jupiter and Saturn hide their cores deep beneath crushing layers of gas, but TOI-849b lays its secrets bare. By studying it, scientists can finally test long-held theories about what lurks at the hearts of these massive worlds. Initial data suggests its core is a mix of rock and metal, possibly with exotic, high-pressure forms of water or other minerals forged under extreme conditions. But here's the twist. TOI-849b's density isn't just unusual, it's too high. Even for a stripped core, it's packing way more mass than expected. Some researchers speculate it might have collided with another massive object in the past, merging into one ultra-dense blob. Others wonder if it's absorbing material from its star, slowly growing heavier over time. Whatever the explanation, this planet challenges our understanding of how planetary systems evolve, and hints that the universe might be full of similarly weird, unfinished worlds. Now, as we peel back another layer of cosmic mystery, let's turn our attention to a planet that's not just strange, but downright glamorous, a world glowing in shades of pink. Leaving behind the dense mysteries of stripped planetary cores, we now set our sights on a world that looks like it's straight out of a cosmic fantasy, J1719-1438, better known as the Pink Planet. Picture a Jupiter-sized world bathed in a dreamy magenta glow, floating eerily in the darkness of space. This isn't some artist's interpretation. It's the real deal, one of the few exoplanets we've directly photographed, and its color alone makes it a standout in the celestial menagerie. Discovered in 2013 by the Subaru telescope in Hawaii, J1719-1438 orbits its star at a distance of nearly 44 astronomical units. That's 44 times farther than Earth is from the Sun. At this vast distance, you'd expect a frozen wasteland, but this planet defies expectations with a scorching surface temperature of 460 degrees Fahrenheit. The secret to its heat, youth. At just around 160 million years old, J1719-1438 is practically a newborn in planetary terms, still glowing from the leftover energy of its formation. That residual heat gives it that striking pink hue, a mix of infrared radiation and the way its methane-rich atmosphere absorbs certain wavelengths of light. What's truly groundbreaking about this planet is how we found it. Most exoplanets are detected indirectly by the shadow they cast as they transit their star or the gravitational wobble they induce. But J1719-1438 was directly imaged, a rare feat made possible by its distance from its host star and its own intense glow. Astronomers used advanced instruments to block out the star's blinding light, revealing the planet's faint magenta shimmer. It's like spotting a firefly next to a spotlight from miles away. This young gas giant also offers crucial clues about how planets form. Current models suggest gas giants like Jupiter start their lives much farther from their stars before migrating inward. But J1719-1438's wide orbit challenges that idea. It's too far out to have migrated, hinting that some giants might form right where they are. Its composition is another puzzle. While it's rich in methane like Neptune, its temperature and color suggest complex atmospheric chemistry, possibly with clouds of silicate particles or exotic compounds we've yet to identify. But here's the kicker: despite its extreme heat, J1719-1438 is technically a cold gas giant compared to others we've found. Its pink glow isn't from scorching temperatures like lava worlds, but from its lingering formation heat, like embers cooling after a fire. That makes it a unique laboratory for studying planetary adolescence, offering a snapshot of what Jupiter might have looked like in its earliest days. As we marvel at this rosy oddball, we're reminded that the universe has a flair for the dramatic, and our next stop takes us to a world where the very ground beneath your feet would boil away into space. Just when you thought the universe couldn't get any more extreme, let's turn our attention to a planet that takes scorching to unimaginable levels, Gliese, a super-Earth where the very ground beneath your feet isn't just hot, it's vaporizing into space. Imagine a world so close to its star that one side is a perpetual ocean of molten lava, while the other might be frozen solid in eternal darkness. This isn't science fiction, it's the brutal reality of a planet dancing on the edge of destruction. Discovered in 2009 by the Cancri Space Telescope, this rocky world orbits its star in just 20 hours, meaning a full year there passes in less than a single Earth day. At only 1.6 million miles from its host star, that's 23 times closer than Mercury is to our Sun. Gliese is tidally locked, with one hemisphere constantly facing the scorching light and the other plunged into freezing shadow. Daytime temperatures soar to a staggering 4,000 degrees Fahrenheit, hot enough to melt rock into vast lava seas, while the night side could be as cold as -350 degrees Fahrenheit. But here's where things get even wilder. Scientists believe CoRoT T7b might literally be evaporating. The intense heat on the day side vaporizes rock and metal, creating a thin, exotic atmosphere of sodium, potassium, and silicon monoxide gas. But this atmosphere doesn't last. The star's relentless radiation and solar wind blast it away into space, stripping the planet layer by layer. Some estimates suggest CoRoT T7b could be losing tens of thousands of tons of material every second, a process that might eventually leave behind nothing but a barren, airless core. What makes this planet so fascinating is what it teaches us about the limits of planetary survival. Most exoplanets we've found are gas giants, but CoRoT T7b is a rare example of a super-Earth, a rocky world larger than ours but smaller than Neptune. Its existence in such a hellish environment challenges our understanding of how planets form and evolve. Did it start farther out and migrate inward, or was it born in this infernal orbit? Either way, its fate seems sealed, a slow, inevitable demise as its very surface boils away into the void. Yet, despite its brutality, CoRoT T7b offers a glimpse into the extremes of planetary science. It's a laboratory for studying how atmospheres form and escape, how tidal forces shape worlds, and what happens when a planet ventures too close to its star. And as we brace ourselves for the next stop on our cosmic tour, we'll encounter a world where even the weather defies all logic, proving once again that the universe loves to keep us guessing. Just when you think we've seen it all, the universe throws us another curveball. Welcome to HT-P7b, the gas giant that plays by its own rules. This isn't just another hot Jupiter, it's a planetary rebel where the weather defies every scientific prediction. Imagine a world where the hottest spot isn't where it's supposed to be, where atmospheric currents shift like sand in a cosmic storm, and where every observation leaves astronomers scratching their heads. Discovered in 2008, HT-P7b orbits so close to its star that a year lasts just 2.2 Earth days. With daytime temperatures soaring past 4,000 degrees Fahrenheit, you'd expect the hottest point to be directly under its star, but that's not the case. Instead, the peak heat shifts dramatically, sometimes appearing east or west of where models say it should be. This bizarre behavior suggests something extraordinary. The planet's winds are constantly changing direction, rewriting the rules of exoplanet meteorology. What makes this inconsistency so puzzling? On most tidally locked planets where one side always faces the star, scientists expect superheated air to flow from the day side to the night side in a predictable pattern. But HT-P7b laughs at expectations. Its atmosphere might be dominated by colossal storms or vast jet streams that redirect heat in chaotic ways. Some theories suggest the planet's magnetic field could be interacting with its atmosphere, or that its clouds, possibly made of vaporized minerals like corundum, reflect and trap heat in unexpected ways. Here's the real kicker. HT-P7b isn't just a scientific oddity. It's a humbling reminder of how much we still don't know. Our models of planetary atmospheres, built on decades of studying Jupiter and Saturn, fall apart when faced with this world. It's like trying to predict Earth's weather by only studying a desert. Some patterns just don't translate, yet that's what makes this planet invaluable. Every strange reading, every flicker of unexpected heat, forces us to rethink our assumptions about how gas giants behave under extreme conditions. As we peel back the layers of this enigma, one thing becomes clear. The universe isn't just stranger than we imagine, it's stranger than we can imagine. And with that, let's set our sights on another cosmic anomaly, where a planet's tilt reveals a violent past that reshaped its entire solar system. Now let's tilt our perspective quite literally, to a planet that spins the rulebook on its head. Meet Kepler 56b, a cosmic oddball with an orbit that defies the norm, tilted a staggering 45 degrees from its star's equator. Most planets in a solar system align like neatly stacked plates, orbiting in the same plane as their star's rotation. But this world, it's more like a drunken sailor wobbling off course, and that tilt tells a story of chaos buried in its past. Discovered in 2012, Kepler 56b is part of a system that left astronomers stunned. Imagine a star with planets circling it at extreme angles, as if someone grabbed the entire solar system and gave it a violent twist. This isn't just a quirk, it's a cosmic scar, evidence of a turbulent history. Normally, planets form from a flat, spinning disk of gas and dust around a young star, inheriting its rotational alignment. So when we find a planet tilted this dramatically, it screams that something catastrophic happened long after the system's birth. The leading theory, a gravitational showdown. Picture this, another star or a massive rogue planet barging into the neighborhood, its gravity yanking Kepler 56b's orbit askew like a bully kicking over a sandcastle. Alternatively, the star itself might have a hidden companion, a smaller, dimmer star or a hefty planet tugging at the system over eons, warping orbits into these bizarre angles. These misalignments aren't just curiosities, they're forensic clues. They reveal how planetary systems can be reshaped by interstellar drama, from close encounters to hidden gravitational puppeteers. Here's where it gets even wilder. Kepler 56b's tilt isn't just a solo act. Its sibling planet, Kepler 56c, shares the same wonky orbit, proving the entire system was thrown off kilter. This duo orbits a red giant star, which adds another layer of intrigue. As stars like this expand in their old age, their gravitational grip weakens, potentially amplifying any existing orbital chaos. It's a reminder that planetary systems aren't static, they evolve, sometimes violently, and the planets we see today are survivors of that cosmic turbulence. What does this mean for our understanding of planet formation? Kepler 56b is a wake-up call. Our own solar system, with its orderly aligned planets, might be the exception rather than the rule. Most alien worlds could be born in chaos, their orbits sculpted by collisions, close calls, or unseen companions. This tilted giant challenges us to rethink how systems stabilize or fail to, and why some planets end up so fiercely independent from their stars. As we marvel at this astronomical rebel, let's turn our gaze to another world where the universe's relentless forces are shaping a planet's destiny in real time, one that's quite literally evaporating before our eyes. Now we shift our focus to a planet that's vanishing before our very eyes. Introducing Kelt 16b, a doomed world slowly dissolving into space under the brutal glare of its star. This ultra-hot Jupiter is losing its atmosphere at an almost unimaginable rate, 10 million tons of gas stripped away every single second. That's the weight of 500 Great Pyramids of Giza vanishing into the void every minute, a cosmic disappearing act playing out in real time. Discovered in 2016, Kelt 16b orbits so close to its star that a full year lasts just 27 hours. Imagine a gas giant like Jupiter, but so blisteringly hot that its outer layers are boiling away into space. Its atmosphere isn't just leaking, it's being blasted off by a torrent of stellar radiation, creating a glowing tail of gas that stretches thousands of miles behind the planet like a comet's tail. This isn't some slow geologic process. We're watching a planetary demolition in fast forward. Here's what makes this phenomenon so extraordinary. We're witnessing the final chapters of a planet's life. Over millions of years, Kelt 16b will shrink from a gas giant to a bare core, its fluffy outer layers completely evaporated. This gives astronomers a rare opportunity to study what might remain a naked planetary core that would normally be hidden beneath thick atmospheres. It's like watching a cosmic autopsy, revealing the bones of a gas giant that most planetary systems keep buried. The physics behind this evaporation is equally fascinating. The star's intense heat excites molecules in the planet's upper atmosphere, giving them enough energy to escape gravity's grip. But unlike Earth's gentle atmospheric loss where hydrogen trickles away over billions of years, Celt-16b's escape is more like a tornado tearing through tissue paper. The planet's low gravity as a puffy gas giant makes it particularly vulnerable, allowing its star to rip away gas at speeds exceeding 100,000 miles per hour. What does this mean for the planet's future? Current models suggest Celt-16b could lose its entire atmosphere within the next 100 million years, a blink in cosmic terms. What remains will likely be a strange, scorched remnant, possibly resembling the ultra-dense cores we've found in other systems. This ongoing evaporation offers crucial insights into why we find so few ultra-close giant planets. Most may have already been cooked down to their skeletons. The most thrilling part, we can watch this process unfold. Using telescopes like Hubble, astronomers measure the planet's evaporating hydrogen tail during each orbit, tracking changes over time. It's like having front-row seats to a planetary transformation that usually takes longer than human civilization has existed. Celt-16b reminds us that planets aren't permanent. They're dynamic worlds that can be reshaped, reduced, or even erased by their stars. As we contemplate this dissolving giant, let's turn our attention to another survivor, one that somehow endured being swallowed by its own star only to emerge hauntingly transformed. Next, we encounter a world that defies all odds, a cosmic phoenix that rose from stellar destruction, presenting Kepler-70b, the mirror planet, a scorched survivor that slipped through its star's fingers and lived to tell the tale. This planetary remnant exists in a realm of extremes, orbiting its host star at a distance 20 times closer than Mercury is to our Sun. Its surface temperature exceeds that of our own Sun's photosphere, reaching a blistering 12,000 degrees Fahrenheit. But here's the astonishing part: Kepler-70b wasn't always this tortured world. It began life as a typical gas giant before enduring one of the universe's most violent transformations. The story begins when the planet's host star entered its red giant phase, swelling to hundreds of times its original size. Normally, this stellar expansion spells certain doom for any nearby planets. Yet Kepler-70b somehow survived being completely engulfed by its star's outer layers, a feat akin to walking through a furnace unscathed. How did it cheat destruction? The answer lies in an intricate cosmic dance. As the star expanded, tidal forces likely stripped away the planet's gaseous envelope, leaving behind only its dense metallic core. This core's compact size and immense gravity allowed it to plow through the star's tenuous outer atmosphere without fully evaporating. Picture a bullet fired through smoke. The dense metal projectile survives while the surrounding gas gets pushed aside. The same physics saved Kepler-70b's core from complete annihilation. Now locked in an insanely tight orbit, the planet completes a full revolution every 5.7 hours. Its dayside surface isn't just hot, it's so intensely heated that heavy elements like iron exist as vapor in the atmosphere. The night side, while slightly cooler, still glows like molten metal. Astronomers believe the temperature difference between hemispheres creates supersonic winds that would make even the hyperwind planet's gales seem gentle by comparison. What makes this discovery truly groundbreaking is what it reveals about stellar evolution. Kepler-70b proves that planets can endure phases we once thought unsurvivable. Its existence suggests there may be other, burnt-out worlds hiding in similar systems, former gas giants reduced to their scorched skeletons. Some scientists speculate these remnant cores could be more common than we realize, quietly orbiting white dwarf stars throughout the galaxy. The mirror planet gets its nickname from another bizarre characteristic: its surface may be so smooth and reflective from constant vaporization and recondensation that it literally acts like a cosmic mirror. As the star's light hits the planet's dayside, some gets reflected back into space with unusual efficiency. This creates a distinctive signature that helped astronomers identify its unique properties in the first place. Perhaps most remarkably, Kepler 70b's survival timeline gives us a glimpse into our own solar system's distant future. When our Sun becomes a red giant billions of years from now, Mercury and Venus will likely meet obliteration, but Kepler 70b shows that under extraordinary circumstances, some worlds might persist through the apocalypse. As we marvel at this stellar survivor, our journey takes us to a pair of worlds locked in an extraordinary gravitational embrace. Now we turn our attention to a celestial oddity that resembles a cosmic ballet, the binary planets Kepler 36b and c. These two wildly different worlds perform an intricate gravitational dance that defies expectations, orbiting so close they could practically reach out and touch each other. Imagine two planets, one a dense, rocky super-Earth nearly 5 times heavier than our home world, the other a puffy mini-Neptune filled with swirling gases. Normally, such mismatched worlds would never orbit this intimately, but Kepler 36b and c break all the rules. At their closest approach, they're separated by just 1.2 million miles. To put that in perspective, that's only 5 times the distance between Earth and our Moon. If you were standing on one of these planets, its neighbor would appear as a colossal world dominating the sky, far larger than our Moon appears to us. What's truly fascinating is how their wildly different compositions create a gravitational tug-of-war. The rocky super-Earth, with its compact mass, exerts a powerful pull on its gaseous neighbor, warping its atmosphere with each close pass. Meanwhile, the mini-Neptune's expansive atmosphere creates tidal forces that subtly reshape the surface of the rocky planet below. These gravitational interactions create tides thousands of times stronger than what we experience on Earth. Yet somehow, against all odds, their orbits remain stable. Astronomers believe their mutual gravitational relationship locks them into precise orbital resonances, a rhythmic pattern where their gravitational nudges balance each other out over time. It's like two dancers spinning in perfect sync, never colliding despite their breathtaking proximity. Their orbits are so finely tuned that the rocky planet completes 6 orbits for every 7 orbits made by its gaseous companion. The presence of these two worlds in such tight formation raises intriguing questions about planetary formation. Normally, gas giants form farther from their star, while rocky planets cluster closer in. Yet here they are, defying that logic. One theory suggests they didn't form this close instead. Gravitational interactions with other planets or the star itself gradually nudged them into this extreme configuration over millions of years. Another possibility is that the mini-Neptune somehow lost much of its original atmosphere, bringing it inward. The contrast between these worlds couldn't be more striking. The rocky planet, likely a scorched wasteland with surface temperatures hot enough to melt lead, stands in stark opposition to its gaseous neighbor, which may harbor exotic forms of ice deep within its thick atmosphere. Yet their contrasting natures somehow complement each other in this cosmic duet. For astronomers, the Kepler 36 system serves as a natural laboratory for studying extreme planetary dynamics. The gravitational interplay between these two worlds creates measurable effects, allowing scientists to test theories about orbital stability, atmospheric distortion, and planetary migration. Some researchers even speculate that similar binary arrangements might exist elsewhere, hidden in the vastness of space. As we marvel at this pair of celestial partners, we prepare to venture to the edge of another star system, where an enigmatic world orbits so far from its sun that its very existence challenges everything we know about planet formation. Now we journey to the farthest reaches of an alien solar system, where we encounter a planet that simply shouldn't exist, HD 106906b, a cosmic rebel that defies all the rules. This colossal world, 11 times more massive than Jupiter, orbits its twin stars at an astonishing distance of 650 astronomical units. That's 20 times farther than Neptune's orbit around our Sun. placing this giant in such a remote region that sunlight would appear as nothing more than a bright star in its sky. What makes this planet truly impossible is its location relative to its birthplace. According to current planetary formation theories, gas giants simply can't form this far from their stars. The protoplanetary disks of dust and gas that give rise to planets are usually too sparse at such distances to accumulate enough material. This leaves astronomers with a fascinating puzzle. Did this world form elsewhere and get flung outward, or was it born under circumstances we don't yet understand? One compelling theory suggests HD 106906b might be a captured rogue planet, a world born around another star that was later stolen by this binary system. Gravitational encounters between stars in crowded young star clusters could have hurled this planet into its extreme orbit. Supporting this idea is the planet's bizarrely tilted orbit, inclined at a sharp angle relative to the debris disk surrounding its host stars. Such misalignments often point to violent gravitational interactions in the system's past, but the most intriguing possibility connects this distant world to our own solar system's mysteries. Astronomers have long speculated about the existence of Planet 9, a hypothetical giant planet lurking in the outer reaches of our solar system. The strange orbits of some distant icy bodies suggest an unseen gravitational influence, much like how HD 106906b dominates its remote neighborhood. Could our solar system have its own version of this impossible planet? Studying distant systems like this one helps scientists test theories about how such extreme worlds come to exist. Despite its frigid location, this planet isn't completely frozen. Observations reveal it still glows faintly with residual heat from its formation, giving it a temperature of around 1,500 degrees Celsius. This warmth suggests it's relatively young, only about 13 million years old, making it a cosmic infant compared to our 4.5 billion-year-old solar system. What's truly mind-bending is imagining the view from this lonely giant. Its twin stars would appear as mere pinpricks of light, while the vast, dark expanse around it would stretch endlessly. Yet somehow, against all odds, this impossible planet persists, a defiant challenge to our understanding of how planetary systems evolve. As we conclude our tour of strange worlds, it serves as a perfect reminder that the universe always has more surprises waiting to be discovered. As we reach the end of our cosmic journey, let's take a moment to marvel at the sheer strangeness of these 25 extraordinary worlds. We've encountered planets with surfaces made of diamond and molten iron rain, where winds howl at thousands of miles per hour and glass shards fall sideways. We've witnessed worlds that glow pink with residual heat, orbit 3 suns at once, or float alone through the void without a star to call home. Each one challenges our understanding of what a planet can be, revealing the universe's boundless creativity. This exploration has reshaped planetary science in ways we couldn't have imagined. The discovery of worlds like HD 106906b defying formation theories with its impossibly distant orbit forces us to rethink how planetary systems evolve. The extreme conditions on WASP-76b, where metal vaporizes on one side and rains down as liquid iron on the other, show us how diverse atmospheric chemistry can be. Meanwhile, rogue planets drifting through space hint that our galaxy might be teeming with nomadic worlds we've yet to detect. Every strange planet we find stretches the boundaries of what we thought possible. What's truly remarkable is how these discoveries connect to our own cosmic backyard. The potential for habitable eyeball planets with their delicate balance of ice and liquid water makes us reconsider where life might thrive. The study of ultra-dense worlds like TY-849b, possibly the exposed core of a failed gas giant, gives us clues about the violent processes that shape planetary interiors. Even the hypothetical planet 9 in our solar system finds eerie parallels in these distant exoplanets, reminding us that the universe loves to break its own rules. So here's the big question: what other bizarre worlds are still waiting to be found? With telescopes growing more powerful every year, we might soon uncover planets made of pure water, shrouded in perpetual storms, or even ones with features we can't yet imagine. The universe has already shown us its capacity for wonder, and this is likely just the beginning. Now it's your turn. Which of these strange planets fascinated you the most? Was it the diamond-studded 55 Cancri E, the eternal triple sunsets of HD 131399b, or the rogue planet wandering the cosmic wilderness? Drop your thoughts in the comments below, and don't forget to like and subscribe for more deep dives into the universe's greatest mysteries. Who knows, the next planet we explore together might be even stranger than the last. Happy stargazing!